So now we'll see the case 4, that is h of n antisymmetric impulse response. Out of these 4 cases, you will get one question, one derivation. So antisymmetric with n, so antisymmetric response, antisymmetric impulse response with n is even. Okay, now we'll see what is the frequency response. For the frequency response from the DTFT, we know that DTFT of impulse response, h of e power j omega is equal to summation n is equal to 0 to n minus 1, because it is a finite FIR filter, finite impulse response. So we have only finite number of samples. H of n into e power minus j omega n. This is equal to, here h of n is antisymmetric with even number of samples. So for example, we assume there are 4 samples. 4 samples. Since it is antisymmetric, the first sample must be equal and opposite to the last sample. If it is 2, this length must be minus 2, this sample. And similar way, this sample is equal to this sample and opposite. Therefore, when you add this, it will become 0. Okay, since it is even, the center of symmetry is in the middle of this, means this center of symmetry is not an integer. It is not an integer. Okay, it is middle of this even samples. So exactly we can divide this total h of n into 2 equal parts. First part is having these samples and second part is having these samples. So there is no middle sample here. Therefore, this summation can be split into 2 parts. And see, in these 2 parts, the last sample of the first part is nothing but, see, if it is n is equal to 4, this is equal to n by 2 minus 1. Means 4 by 2 minus 1, that gives 1. And this sample is n by 2. Correct? N by 2, 4 by 2, it will be 2. You take any n value may be 4, 6, 8, any value you can take. This is the value. The last sample of the first half is equal to n by 2 minus 1, and first sample of the second half is n by 2 sample. So the summation limits I can change from 0 to n by 2 minus 1 for the first half samples of h of n, and second summation I can write n value from n by 2 to n minus 1, h of n e power minus j omega n. Okay, this is equal to this. I'll keep it same for some time, n by 2 minus 1 h of n into e power minus j omega n. But here the summation limits are different. I want to club these 2 terms, so I have to change the summation limits. Therefore, I'll keep n minus 1 minus n is equal to p. Therefore, as n tends to n by 2, p tends to, if it is n by n by 2, then I can write it as n minus n by 2 will be n by 2 minus 1. And as n tends to upper limit is n minus 1. As n tends to n minus 1, p tends to, if I substitute n minus 1 here, this both will be cancelled. So p tends to 0. Therefore, this summation can be written as p is equal to n by 2 minus 1 to 0, h of n minus 1 minus b, because n is equal to from this n minus 1 minus b into e power minus j omega of n minus 1 minus b. Okay, now this summation limits can be make it volta, upper limit lower limit we can exchange because it is a summation only. And also here in place of p, again I will keep it back small n. So I'll keep n in place of p. I can keep it any because p is a variable. I'll make that p variable as n. So summation n is equal to 0 to n by 2 minus 1 h of n into e power minus j omega n plus this summation n is equal to 0 to n by 2 minus 1 h of n minus 1 minus n into e power minus j omega of n minus 1 minus n. Right. Here both summations are equal, so I can club this. And here, since h of n is antisymmetric, h of n is antisymmetric. What is the condition for antisymmetric? The first sample is equal to the minus of last sample. Okay, because of this, this can be written as minus h of n. Therefore, I can club these two summations. Therefore, the frequency response is summation n is equal to 0 to n by 2 minus 1 h of n. This is minus j omega n, and here it is minus h of n. So minus e power minus j omega of n minus 1 minus n. Okay, and here this is looking like e power j theta and e power minus j theta, correct? So in order to make in a proper way, it is not as it is like that, but we can convert it to that fashion by doing something that you just multiply with minus j of, so just take common e power minus j of n minus 1 by 2 from both the terms. Since this is an extra term we have taken common from these two terms, I will just compensate this extra factor by adding this, by multiplying this extra term. Okay, then it will be again same term, e power j n minus 1 by 2, sorry, omega into e power minus j omega of n minus 1 minus n. Okay, here this is equal to e power minus j omega of n minus 1 by 2. You keep it as it is. Summation also keep it as it is. H of n into these two terms, you just club it. Take omega common and j, e power j omega of. What you can do here, n minus 1 by 2, and here minus n and minus. Here also you take common minus j omega from these two terms. Therefore, it is first n minus 1 minus n, and this is minus n minus 1 by 2. Okay. Here see n minus 1 and this is n minus 1 by 2. So resultant will be n minus 1 by 2. Therefore, h of e power j omega is equal to e power j omega of n minus 1 by 2 into sorry, summation summation n is equal to 0 to n by 2 minus 1 h of n into e power minus sorry plus j omega of n minus 1 by 2 minus n minus e power minus j omega of n minus 1 by 2 minus n. Right? See here now, this can be written as, this part can be written as 2j sine omega of n minus 1 by 2 minus n. Correct? So in place of this, I can write this. Therefore, this is equal to e power j omega of n minus 1 by 2 into summation n is equal to 0 to n by 2 minus 1 h of n into, this is 2 j, I will keep it outside. Okay, next time I will write this j out. This is into 2j sine omega of n minus 1 by 2 minus n omega. Here j I will take it out, and also I will write j is equal to e power j pi by 2, because j is equal to e power pi by 2 into e power j omega of e power j omega of n minus 1 by 2 into summation n is equal to 0 to n by 2 minus 1 h of n, sorry, into 2 into h of n into sine of n minus 1 by 2 minus n into omega. Right. Okay, now these two exponentials we can club. So it is e power j of pi by 2. This is minus, right? But Sandhya, is it minus or plus? Sirisha, are you there?
Yes, sir.
Sirisha, is it minus or plus? Not listening. Okay. See, it is minus here. It is minus. Minus. Here, sorry. Here it is minus. Here it is plus. So it is minus n minus 1 by 2 omega into summation of this. But here I will assume this. Okay, next step I will assume n is equal to 0 to n by 2 minus 1 to h of n sine of n minus 1 by 2 minus n omega. Okay, here this inside of sine we have n by 2 minus 1. Since n is even, then n minus 1 by 2 is not an integer, right? It is not an integer. So the sign of non-integer value minus n will give you its uncomfortable sign values. I mean, it's difficult to calculate these values. So we need to find out a integer value. So I will replace this value with some other by assuming this p. So I'll shift this value. So I'll assume p is equal to n by 2 minus 1. So I'll assume this index value to a small value, some other value, p value, which is equal to n by 2 minus 1. Now, if a p value is equal to n by 2 means it is even value, you will get one integer value minus 1. So total it will give minus value only. Therefore, I will change this limits, summation limits as n tends to 0. What about p? P tends to, sorry, this is minus n by 2 minus n, not minus 1. So I will take it n by 2 minus n by 2 minus n. Therefore, it is p is
n by 2.
n by 2. Very good. And as n tends to n by 2 minus 1, then p tends to 1. Correct? N by 2, if I place, it will become plus 1. Therefore, this h of e power j omega now is equal to e power j of pi by 2 minus n minus 1 by 2 omega summation limits change. Now p is equal to uh, n by 2 to 1 into h of 2 into h of what is that, h of n. So what is n from here? N by 2 minus p, n by 2 minus p into sine of this is equal to n by 2 minus n is replaced with p. So p minus 1 by 2 into omega. So this is equal to, here I will assume this pi by 2, let pi by 2 is equal to beta, shifting phase shift is beta, and n minus 1 by 2 is equal to alpha. Then it is equal to e power j beta minus alpha omega, and summation here it is equal to, here it is, I will change the limits and I will keep n in place of p. So it is n is equal to 1 to n by 2, 2h of n by 2 minus n into summation n minus 1 by 2 into omega. Okay. Now I will just simplify this with some assumption, that is e power beta minus alpha omega into summation n is equal to 1 to n by 2, and this I will assume as d of n, this part, and the remaining part I will keep it same, sine of n minus 1 by 2 omega. Okay, where d of n is equal to, where d of n is equal to 2 into h of n by 2 minus n. Okay, for all values of n, that means for n is equal to 0 to n minus n. Therefore, from this we know that the frequency response of an FIR filter is represented as a magnitude response that is giving by the previous expression. This total, I'll assume it as h cap of e power j omega. Okay, that is a zero phase frequency response into e power j theta of omega. Okay, where h cap of e power j omega is equal to summation n is equal to 1 to n by 2 d of n into sine of n minus 1 by 2 into omega, and theta of omega is equal to beta minus alpha omega, right? This is the frequency response of a linear phase FIR filter when the h of n is antisymmetric and n is odd, n is even. So if you draw the plot, magnitude response, if you want, h cap of e power j omega from this is equal to, it is a sinusoidal wave, but it is half only every time. The phase is getting minus 1 by 2 omega. Therefore, it will get the magnitude response like this sine wave, then again repetition for the next half. This is the non-zero phase frequency response. And when you do the same thing for this magnitude response, because this magnitude response of this is equal to magnitude response of this, right? That means there is any negative portion in the h graph of e power j omega, that will be converted into positive only. Since here there is no negative portion, this will be same as this one, same as this one, same as this one. In the previous example, previous cases, we got some negative portion in the h cap of e power j omega, that was converted into positive side for magnitude of h of e power j omega. Okay. This is about the magnitude frequency response of linear phase FIR filters. The 4 cases over. Any doubt here? Please let me know. I'll clarify. Then I'll go to the next point. Any doubt, Sandhya?
No, sir.
Okay. So this is the theory question only. In the 4 cases, you may get 1 question. Now, shall I start the next topic? What, Sandhya? Shall I start next topic?
Yes, sir.
Okay. So next topic is FIR filter design. FIR filter design. Now we'll go to the linear phase FIR filter, how to design. So this linear phase FIR filter is designed happened in 3 ways. So we have 3 methods to design the linear phase FIR filter. That one is Fourier series method. Fourier series method. Second one is window technique. Or window method. Last one is frequency sampling method. Frequency sampling method. Okay. Done. These 3 methods, if you learn now, that what is that FIR filter design is over. That concepts. Now total this filtering process will be over by these 3 topics. After that, in the 3rd module, 3/4 will be over by these 3 concepts. Next 1/4 is about the DSP processor, that is full theory. Okay, so in these 3 methods, you will get definitely 1 or 2 problems in the main exam. In that, windowing technique all is compulsory. 1 problem from here. And in our syllabus, this Fourier series method is not given. It was in earlier syllabus, but just for sake, for betterment, I'm going to start with the Fourier series method first. And second question you will get from this frequency sampling method. So I'm expecting one question from windowing technique, one question from frequency sampling method. And this Fourier series, as per your syllabus, it is not there, but you may get it. But we can't say it is out of syllabus. Okay. Understood? Any doubt? Shall I start first Fourier series method now?
Yes, sir.
Yes, I will start now this Fourier series method. Fourier series method. In this class, I can explain only the procedure. Problem we will see in the next class. Fourier series method. In the Fourier series method, we have to design the filter, right? Filter design is nothing but what? Based on the desired frequency characteristics, we need to calculate what samples and how many samples we need to take, and with what center of symmetry, because it is FIR filter, right? Finite number of samples only we need to take it. Okay, that center of symmetry and how many samples we need to take, this matters our desired frequency characteristics. So first uh, let us assume our desired frequency response as hd of e power j omega. If you take h of e power j omega, that will cover the entire frequency range, but entire frequency range may not require. It covers entire omega range, entire frequency range. But this total range we don't want for the filter design. We want some set of frequency components to allow either low pass or high pass, band reject, whatever. It covers only a part. So say our desired frequency response is this one. And by the DTFT formula, we can express this desired frequency response as summation n is equal to minus infinity to infinity hd of n into e power minus j omega n. Here n covers from minus infinity to infinity, but we need to define how many number of samples we need to take for getting the desired frequency response. Therefore, where hd of n is calculated based on the desired frequency response. So they will give in the problem what is our desired frequency response. From this, we need to calculate hd of n by taking inverse IDFT, inverse DTFT. So by inverse DTFT formula, we have 1 by 2 pi integral minus pi to pi hd of e power j omega into e power j omega n d omega. And see here, the omega range is from minus pi to pi radians. So we are designing the filters like this, minus pi to pi, okay, in this range. So total one period from minus pi to pi. So then now the center will be at 0. Okay, it is not at some value. If your filter response is taking from 0 to 2 pi, then the center will be not at 0. So just remember this point. Now we are considering from minus pi to pi. And from this, if you know once this desired sampling, desired impulse response sequence, we can find out, we can design in the digital filter, right? FIR filter is a digital filter. So how to get the digital filter? That means this frequency also in the digital manner. So I can find h of z from this hd of n, because it is a discrete sequence. I can find out h of z from the Z transform formula. So it is summation n is equal to 0 minus infinity to infinity hd of n into z power minus n, right? And see here, because of n value from minus infinity to infinity, this represents a non-causal filter, and also from minus pi to pi you are taking. This represents a non-causal filter. Okay. Till this point, you remember this. Later we'll convert into causal. Okay. H of z we got so far. And here HD of n is a desired frequency response, desired impulse sequence. HDFN is a desired impulse response. Impulse response. Right. This is our desired impulse response. But we have H of n is entire frequency, entire impulse response. Therefore, we define H of n is equal to HD of n only for a desired range. Say that desired range is in between n minus 1 by 2 to n minus 1 by 2. Okay. So we have only some set of values, half values from negative portion and half values from the positive portion. Okay. Let us make it a center is a 0 point now. Therefore, we define like that. So desired samples are only finite samples from H of n, and remaining values we consider it as 0. Okay, else all the values are zeros. Therefore, now H of z is equal to summation n is equal to, now HD of n sequence is ranging from minus of n minus 1 by 2 to n minus 1 by 2. Okay. In this range only we have the H of n samples. Sorry, reverse I wrote. H of n is equal to H of n. H of n in this duration. For remaining out of this range, H of n is equal to 0 only. So we have this range H of n into the z power minus n. Okay, when you expand this, if you expand this, H of minus n minus 1 by 2, minus of n minus 1 by 2 into z power minus of n minus 1 by 2 plus and so on, plus somewhere it is h of minus 1 into z power 1 plus h of 0 plus h of 1 z power minus 1 plus and so on, plus h of n minus 1 by 2 into z power n minus 1 by 2. Sorry, it is plus here. It is minus of n minus 1 by 2, right? Now from this, I can write, in general, I can write this is h of n means this is h of minus n, right? And so on. This is like n value from minus 1 by 2 to minus 1. And here the value from n is equal to 1 to n minus 1 by 2. Therefore, I can write this is like h of n sequence, and this is equal to h of minus n sequence, right? That way we can just club this. I can write in the summation way, like this is equal to h of 0 is the middle point, I will leave it, plus summation n is equal to 1 to n minus 1 by 2 into h of n, sorry, h of minus n, first term, first of h of minus n into z power n. Okay, I can write this. And second half is like summation n is equal to 1 to n minus 1 by 2 h of n z power minus n. So when you just club these two and you assume h of n is a symmetric. For h of n symmetrical, h of n is equal to h of minus n at center 0. Okay. Therefore, this h of z can be written as h of 0 plus summation n is equal to 1 to n minus 1 by 2 h of n into z power n plus z power minus n, right? Taken common. And see here, because of z power n, this is non-causal, right? This makes non-causal. This is causal only because it depends on the past values. But here, this depends on future values. Therefore, it became non-causal. Because of this non-causal future values, how can you realize it? So it is not realizable. Not realizable. This system is not realizable. Therefore, we have to change this to full causal system. How to do it? We can do it by multiplying this total with z power minus of n minus 1 by 2. So total will be shifted. So this can be assumed as h dash of z, means which is physically realizable just after multiplication with some delay. So take the same formula, just multiplied with an extra delay term. That is delay of center of symmetry. That will shift everything to a causal side. That means we have so far these points. Like this now it is shifted. This shifted to n minus 1 by 2 points. That is why it is delayed. Extra delay we added. So this total thing is starting from this point. That's it. Total same signal, just shifted. So this non-causal became causal now. So which is physically realizable. Okay. Understood this? So for doing the problem, they will give hd of e power g omega. We should calculate hd of n by taking inverse DTFT formula. From this, we have to select only finite number of samples, and from this we have to calculate h of z. After calculating h of z, it is not physically realizable because of non-causal system. Therefore, we need to multiply the delay at center of symmetry. Then we get the h dash of z. This is the physically realizable FIR filter. That's it. This is the flow of doing the problem. Okay, we'll do the problems in the next class. Any doubts, you just ask me, I'll clarify. Any doubts? Sandhya, any doubts?
No, sir.
Okay, so I'll close here. In the next class, we'll do the problems on this. Please, all of you get your calculators. Be ready with your calculators. Otherwise, it is very difficult. So please come with the calculators. We'll start tomorrow problem. Thank you. We'll meet in the next class.